Alright nerds, so now we're going to talk about esters, and in particular something called esterification and the nomenclature, so the naming of them. Alright, so by the end you should be able to give the IUPAC name for alkanols, alkanoic acids, and esters. Okay, not a big deal. You should also be able to explain, or at least describe the process of esterification, and then we'll do it in class in the next lesson. Alright, so you need to remember the IUPAC system for naming alkanes and alkanols, like methane, ethane, propane, and so forth. Let's start with alkanols. Now, they're a homologous group of organic compounds with a hydroxyl group, which is this OH minus right here. The general formula is ROH, and R is essentially the carbon chain, the saturated carbon chain. So you've got alkenols and alkynols as well, but we're going to focus on alkanols. So here's the general formula for the chain, which is CnH2n plus 1, which if we put it together, the general formula for an alkanol is CnH2n plus 1 OH. Cool. So with the hydroxyl group, they're clearly a polar molecule, which just gives us hydrogen bonding, but also means that they're more soluble. Okay, so they're soluble, and if you get the longer the chain, okay, and this is the same with alkanoic acids, which we'll talk about next. The longer the chain, the more soluble they are. No, sorry, the longer the chain, the lower the solubility, and the higher the melting and boiling points are. Okay, so these also react with alkanoic acids to make esters, and we'll see what they are in a second. So here's 2-butanol. So but meaning 4, 1, 2, 3, 4. That's butane. The little hydroxyl group there makes it, and the hydroxyl group here makes it an ol. So it's butanol, 2-butanol. Alkanoic acids. Alright, so alkanoic acids, they're very large, as with most organic chemical families. They're a very large family of organic acids called alkanoic acids. Mostly we've dealt with inorganic acids, but now we're going to start looking at these. And so this is a carboxylic acid, and this is how this stuff all fits into what we're doing. So carboxylic acid group is this section here of this molecule. And I'm just going to get rid of that. So basically, they contain a carboxylic group, which is the COOH, and that's why it's written OH and not CO2. If it was just COO, like along this one chain, it would be written as CO2H, but that's not it, and you can never write it like that because it is CO. It just indicates that it's a different structure. So the general formula is CnH2n plus 1, just like the alkanols, COOH. Okay, so ethanoic acid, so ethane, meaning it has 2, and the oic acid goes off. So this C here, this part of the carboxyl group, that actually makes up part of the chain. So a carboxyl group is polar, and very strong hydrogen bonds are formed. Now this is key. So they're stronger than, much stronger than you get with alkanols, and the strength of that is why we need to have H plus ions in esterification. And this is why we need that. So it's that strong bonding. Now the strong hydrogen bonding means, yes, it's soluble in water, and it means it has, but because it's a really strong hydrogen bond, it means it has higher boiling points and melting points than similar size alkanes, alkenes, alkynes, and alkanols. That's the really strong hydrogen bonding. They also react to form esters, which we've mentioned, and they do this with the alkanols. And that's called esterification. So here's how we name a couple. First, we've got methanoic acid right here, the 1 carbon. Ethanoic acid, 2 carbon. Now remember, even though this is our carboxyl group, its carbon still goes into the naming. Propanoic acid, 3 carbons. Alright. Now, an ester. Well, Esters are cool, and esters are found throughout nature. They're basically fats and oils tend to be esters. Anything that's got a fat in it or an oil in it, it's usually, well, it is an ester. That's what they are. So they're organic compounds with the formula of RCOOR. Now you notice the H is gone, and that shoots off during esterification here to make water. They are short chain esters of volatile liquids, whereas long chain esters tend to be soft solids or waxes. Now, that's what waxes are. Waxes are large piles of fat. So let's have a look at the reaction just here for esterification. So this here is you know what? I'm not going to rewrite that because that will take away what sit over top of the next thing. So this is esterification right here. You have a carboxylic acid plus an alcohol or an alkanol in presence of a strong acid, so hydrogen ions. So that's a catalyst. Gives you an ester, plus water. The other way to draw it here is here's your R group. This is what makes this a carboxylic acid. Then we've got this, which is what makes this an alcohol. Now we draw it like this because when we draw the chain, you have an acid section, an acid part, and an alcohol part. So the carboxylic acid plus the alkanol gives you an ester plus water. All right, so here's a quick bit of a thing of what esterification is. This is esterification right here. So you've got propanoic acid plus methanol. Okay, so this the acid gives you methyl, which is this section here. So here's the alcohol part. Now we name that part first. We name the alcohol part, the acid part second. So methyl propanoate. Okay, so propanoic acid plus methanol gives you methyl propanoate plus water. All right, cool. Now the way we name them is they're essentially named after the alcohol and the carboxylic acid that they're made from. Again, the alcohol gets the first part of the name, even though we always draw it on the end here. So the alcohol gets the first part. Second part is the alkanoic acid, and we get rid of ANOIC and replace it with ANO8. Okay, so that's how it's named. So you name the alcohol part first, then the ethanol part. Then the alkanoic acid part, and you make it O8 in the end. So if this has an extra C there, with its H is coming off, this becomes methyl propanoate. No, methyl propanoate. And if we put an extra C there, it becomes ethyl propanoate. And another C, propyl propanoate. So yeah, so that's it. And here are a couple of our examples. Here is methyl propanoate. Okay. Here is ethyl, because again, see this part here is what comes off the acid part. Ethyl ethanoate. Butyl methanoate. Okay, so that's the acid part. Here's the alcohol part. That's the acid. All right, so that's esters. Now we're going to make some of those in class, and that should be fun. It'll take a while, but yeah, let's get into it.